Hello everyone. So today I've come with a lesson in physics on levers, and to know levers at first you have to know about machine. So to know this, at first you have to know the basic three concepts, and the basic three concepts you can well relate on the screen that I am presenting and showing you. So the three basic concepts that you have to know is about the effort, load and mechanical advantage. These three are the main components to know a lever, and levers are used for mechanical engineers, and they use these formulas that we are going to see in the below pages. But at first, to know the basic concepts, we have to refer to the first page of this study material. So at first we have to know what is our effort, and what is means by which thing we can relate or know, okay, rather know that it is the effort. So if you focus on the screen, you can see when energy is supplied to machine, it does some work. So to do some work, a force is applied, therefore this force is called the effort. So as I have told you that this thing is related to machine, so to do work on machine, somehow some effort is needed to be put in it. Rather, if it works on electric, okay, if the machine works on electric, we have to plug in the components of that machine to supply electric to it, and then switch on the switches that are present there. So somehow some efforts are given to make our work easier by the machine. Okay, so this is the basic meanings of effort. So I repeat myself, when energy is applied to machine, it does some useful work. So to do some work, a force is applied, therefore this force is called the effort. Now coming to the second thing, what is the load? As a result of effort, the machine which is doing the work lifts or moves an object called the load. So when we are putting some effort, or we are putting or supplying electric to it, it does some work, rather packaging some fruits, or making some ornaments, jewelries, or making some packets. Okay, so some effort is done by the machine, which is known as the load. So to do a work on machine, the energy we are putting, that is known as the effort, and the output we are getting, that is known as the load. Okay, here output means the result or the work that is done by the machine. Okay, so effort we can relate over here, effort is equal to input, and load is equal to output. Now coming to mechanical advantage, so the factor by which a machine multiplies the force is called the mechanical advantage. So over here, what you can understand from here, that the factor by which machine multiplies the force applied. Okay, so when we are doing a work on machine over here, I mean that whenever we are doing a work on machine, um, the output and input may be greater than each other. Then means one can be greater than the other, then one can be less than the other, or else it can be equals to the load and the effort. Means output is to you input. Okay, output is to input. So we can relate like this. Now uh, so mechanical advantage means the result we are getting. Okay, so mechanical advantage means the result we are getting. Okay, so multiplies the force applied. Over here this line means multiplies the force applied. This line means that the mechanical advantage finds out the result of the output. Okay, it finds out the result of the output, whether it is our profit or it is our loss. Now we can think over here that there must be some ratio or some sum to find out mechanical advantage. Okay, there must be a logic behind it. Yes, so there is a logic, that is, if we find out by ratio, making it as a ratio, so it will be load is to effort. Otherwise, if we take it as fraction, load by effort, it would be mechanical advantage and which is load by effort. Now here are some three important points given, which is by calculation. Okay, at first um, I'm telling number one. Okay, so I'm telling this one, number one. Now by calculation, if the mechanical advantage is greater than 1, then it is profited. Here effort will be less than the load. Now what we can understand from here is, if the mechanical advantage is more than 1, suppose 2, 3, 4 and so on, it's infinite. So if it is greater than 1, then it is our profit. Okay, we cannot say it is our loss, because we are giving less effort and we are getting the load rather the output much. Okay, it is greater than the input. The output is greater than the input over here. So if we write over here, so over here load is greater than effort. Okay, L means load and E means effort. Then by calculation, if the mechanical advantage is less than 1, then it is loss. Here effort will be more than the load. Now if we are getting less than 1, suppose -1, -2, rather 0, like this something, then our mechanical advantage will be less than 1, and over here we are getting it as a loss. Okay, because we are putting the effort more but getting the result less. Okay, more effort is provided but less output is less output is got. Okay, now if we tell over here, now over here effort is greater than the load. Okay, E means effort, L means load. Now coming to the third point, by calculation, if the mechanical advantage is 1, then it is neither profited nor loss. So by mechanical advantage, by calculation, if we see that the answer we get is 1, then the effort is equals to the load, means the amount of effort we have put into the machine. Okay, so the amount of effort we are putting into the machine, the same amount of load we are getting from the machine. Here effort is equals to the load. Now here it is neither profited nor loss. Now one example is given here. A machine requires an effort of 10 kgf for a load of 50 kgf. Find its mechanical advantage. Now coming to the solution. Mechanical advantage, load by effort. At first we have to copy the formula which is given over here. Then we are going to put the numbers. Load we can find over here. Load is equal to 50 kgf. Okay, we are going to write it over here, and effort is equal to 10 kgf. Effort is equal to 10 kgf. We are going to write it over here. Okay, so over here load is always in the place of numerator and effort is always in the place of denominator. Now by calculation, if the answer we get is 5. Now we have come to the basic concepts. We have overcome the basic concepts rather. Now we can directly proceed into our main concept, that is levers. That is our main objective over here. Levers are our main objective of this video. Now you can find over here, what is a lever? The definition of a lever is given over here. A lever is a simple machine which we most commonly use in our daily lives. So lever is a simple rod. Okay, in the next line we are going to read about it, but before reading that line, I am just giving you some extra information. As over here it is told that lever is most commonly used in our daily lives, so we can take it as a common component of our daily life. Now what is that common component? That is the rod. It's type of a rod. Okay, now if I give you an example, suppose seesaw, which you can find in the park, outside parks. Over there one pass in the middle, one long rod type thing is there where children used to sit and play. Okay, the two both ends children used to sit and they used to play with it, so that thing we can take it as a lever. Okay, so that is our main thing over here, that is the lever. Now there are many things in lever. There are three types of lever, but before proceeding into it we have to also know one more thing, that is what is a fulcrum. Now in this line you can find, in this line, okay, in this line, you can found that in its simplest form a lever is a rod which can turn about a fixed point called the fulcrum. So in its simplest form means in its easiest form, or rather the easiest way, lever is a rod. See over here my word is given, lever is a rod which can turn about a fixed point called the fulcrum. Now if we take the example seesaw, over there one thing is attached in the middle, that is known as the fulcrum. So it is the main point from where it can move up and down. Okay, the both the ends can move up and down, and that thing we can relate to this definition of fulcrum. So we can take that thing as the fulcrum. Now coming to three types of lever. Now there are three types of lever: lever of class 1, levers of class 2, levers of class 3. Now before knowing these three classes of lever, we have to know the principle of a lever. Now what do you mean by the principle of a lever? Principle means the main mean. Over here, that not the school principle about which I am talking. It is about the principle that uh, over here the principle means the main objective or the IQ of this lever. Okay, now there is a one diagram is given over here. Now if we take this point triangle, okay, as over here I have drawn it as a triangle. It can be it cannot be a square because triangle is more prominent over here. So this is the fulcrum, okay, as F is given over here on top. F means fulcrum, it is given in its short form. Now let us come to the paragraph given over here. Figure 1 shows a rod AB which can turn about a fixed point F. F means fulcrum. The rod AB thus behaves as a lever, the fulcrum of the lever. It is an effort E is applied at the one point A on the lever and load L is exerted at the another point B. The distance FB of load from the fulcrum F is called the load arm, and the distance of FA of load from the fulcrum is called the effort arm. Now what we can relate from here, that is FA means we are talking about this part, and FB means we are talking about this part. Okay, so over here B means load, as B below above load it is written B, and above effort it is written A. So over here load means B and effort means A. So the distance between an effort and the fulcrum is known as the effort arm, and the distance between the load and the fulcrum is known as the load arm. Now over here it has been told that FA means A means effort, we already know A means effort. So AFA is equals to effort arm and FB is equals to load arm. Now as we already know that the main formula to find out a mechanical advantage is load by effort, but in the place of levers there is a change, and it is the reciprocal. It is the reciprocal of the mechanical advantage of a normal machine. I repeat myself, the formula used for a simple mechanical advantage of a machine is the reciprocal for the formula to find out the mechanical advantage of a lever. Now over here you can find out when the lever is in the balanced position, it is found that load into load arm is equal to effort into effort arm. Okay, but this is not the formula to find out. The main formula is mechanical advantage of a lever is effort arm by load arm. Okay, so normally we know the formula is load by effort, but in case of arm means we know that it is telling something about the lever. So mechanical advantage load by effort, as I have already told, is the reciprocal over there in this case. So we know arm means related to lever. So over here it will be the reciprocal, effort arm by load arm. Over here this term arm is very important, okay, because it is the only way to find out that yes, it is telling something about lever. Now there is one line, three lines given below. Thus the mechanical advantage of a lever is equal to the ratio of the effort arm to the load arm. This is called the mechanical advantage. So you can find out, it is given in very simple language, the last three lines. So I don't think that I have to explain much over here. Now directly proceeding into the three classes of lever. Now at first we are proceeding with levers of class 1. So over here the lever in which the fulcrum is between the effort and the load is called levers of class 1. So over here the mechanical advantage can be less than 1, more than 1, or uh, equals to 1. Now how we will know that when effort arm is greater than the load arm, that it is our profited or it is our loss? How we will know that? So at last I've given 2 points, that is if the mechanical advantage is more, okay, when the mechanical advantage is more in effort arm than in load arm, then it is our profited. And if the mechanical advantage is the mechanical advantage of load arm is more than the effort arm, then it is our loss. So what is it written here? Mechanical advantage is more when the distance between effort to fulcrum is more than the load to fulcrum. Mechanical advantage is less when the load arm to fulcrum is more than the effort arm to fulcrum. So over here you can find out that if the fulcrum, now let me just explain quickly about the levers of class 1. Over here fulcrum will be between the load and the effort, okay, fulcrum will be in the between. So the most prominent and easiest example of this will be seesaw. See, I have already written over here, some more examples are there, we will come to it later. At first we have to know about the mechanical advantage over here. So here the mechanical advantage of class 1 can be greater than 1, equal to 1, or less than 1. So if the fulcrum is faced little more towards the effort arms, then the load distance between the fulcrum and the load arm will be more, and then it is our loss. If the fulcrum is faced much towards the load arm, then the distance between the effort arm and the fulcrum is more than the load arm, so it is our profit. And if the fulcrum is in the between and neither, means nor of the distance is greater or smaller, less, means no distance will be greater or smaller than each other, then we can tell that it is equals to 1. Okay, so over here some examples are seesaw, pair of scissors, a pair of pilers, beam balance, a crowbar, and a claw hammer. Now coming to levers of class 2. Over here what we can relate is the lever in which the load is between the effort and the fulcrum are called the levers of class 2. So over here the load will be between the fulcrum and the effort. Now the distance between the effort arm and the load arm varies much in this class. Now over here it is given that here the mechanical advantage of levers of class 2 is always more than 1, because in whatever place in between the fulcrum and the effort, in whatever place you place the load arm, it can never reach the place more than the effort arm. I repeat, the distance between the effort and the fulcrum will be always more than the load arm, because the load can never become more than the effort, as the fulcrum and the effort are in the both ends. So over here the mechanical advantage is always greater than 1, because here the effort arm is more than the load arm. Now some examples are given: nutcracker, wheelbarrow, mango cutter, paper cutter, lemon squeezer, bottle opener, etc. Now coming to the third and the last levers of class. Now this is namely levers of class 3. Now what is its definition? Its definition is the lever in which the effort is between the load and the fulcrum are called the levers of class 2. Now over here the load and the fulcrum will be at the two ends and the effort will be in the middle. Now over here the mechanical advantage will be always less than 1. So I have already written over here that here the mechanical advantage of levers of class 2 is always less than 1. So it is our loss over here. Now how we can tell that it is our loss? Because the as load and fulcrum are in the two ends, effort can never reach the distance more than the load. Okay, so over here the greatest arm from the fulcrum will be always the load arm. So therefore here the mechanical advantage is less than 1 and thus it is our loss. So let us do a quick recap, not about the levers, about the loss and profits of this levers. So levers of class 1, over here it can be loss also, it can be profited also, or over here it can be neither profited nor loss. Then in levers of class 2, here it will be always profited, and lever of class 3 it will be always loss. Now coming to a quick recap from the first. So not from the first, only the first two things which is very important: effort and load. Okay, so I am just doing again a quick recap on effort and load. That is, effort is the energy that we are putting into the machine, and load is the output we are getting from the machine or the work processed by a machine. Okay, so hope you can understand this video on levers. If you like my video, please like, share and subscribe it. Thank you.